Today we're going to tackle paper 2. Before we dive in, head over to my website firstfactor.net. You'll find a link in the description. Download the paper, give it a go, and then come back here to see how you did. So a few people have asked me on the science behind how I create my predictions, and I've looked at the past 5 years worth of exam papers, and I've looked at every single topic that has come across those 5 years. And what I've got here is a chart showing that. So what you can see is that equations of a line comes up 140% of the time. So what that means is it's coming up more than once per paper. And I've done this for every topic. And what I'm really focusing on here is everything that is above more than 60%. That tells me it's pretty likely to come up when you do your paper 2 for maths. So I've got about 17 topics here that are more than 60%, and I've built the paper around those 17 topics. That's not to say I don't put other topics in there and stuff which has a lower likelihood, but I've really tried to build a comprehensive paper on what I think is most likely to come up. And this chart is the basis of it. With all that said, let's get into paper 2. Question 1, we have to write the prime factors of 120 and 75. So we're going to use prime factor trees. 120, how do we get 120? Well, that's 60 times by 2. Then how do we get 60? 30 times by 2. How do we get 30? 15 times by 2. And then to get 15, it's going to be 5 times by 3. At this point, we've now got everything to our prime numbers. So our prime factors of 120 is 5 times 3 times 2 times 2 times 2. So we can write that as 5 times 3 times 2 cubed. And let's do the same for 75. So 75 is 25 times by 3, and 25 is 5 times by 5. So to get 75, we have to do 5 times 5 times 3. And that is the answer to question 1, part A. So to find the highest common factor, we're going to use the answer from part A. So we have 120 is 5 times 3 times 2 times 2 times 2. 75 is 5 times 5 times 3. The numbers that we have in common between the two, we have the 5 and the 5, and we have the 3 and the 3. So in order to find the highest common factor, you simply look at the ones in common. So the 2 in common are the 5 and the 3, so you simply do 5 times 3, and that gives you 15, and 15 is our highest common factor. Part C is very similar, so we're going to combine the numbers that are in common. So we have the 5 and we have the 3. So we're going to put down 5 times 3. Then we're also going to multiply the numbers that we haven't circled. So we also have another 5 here, a 2, 2 and a 2. So we're going to times by 5, times by 2, times by 2 again. So this is a calculator paper, so we can just put this into the calculator. 5 times 3 times 5 times 2 times 2 times 2. And that gives you 600. So our lowest common multiple of 120 and 75 is 600. Here we need to draw the graph of the straight line 2x minus 1 equals 4. And we're told it has to be on a set of axes for values of x from 0 to 6. So let's start off by rearranging this and make y the subject. In order to do that, we have 2x minus y equals 4. Let's add y to both sides. Gives us 2x equals 4 plus y, and then subtract 4 from both sides. So you have y equals 2x minus 4. Let's put that into an xy table. We know our values of x have to be 0, 1, 2, 3, 4, 5, and 6. Now we can use our formula, our equation, and put the values of x into there to get our corresponding values of y. So if we put 0 into here, you're going to get minus 4 as your value of y. If you put 1 in, you're going to get 2 times 1 minus 4 gives you minus 2. If you put 2 in, you're going to get 0. And you can actually notice a pattern here where it's going up by 2. So you don't necessarily need to keep using your equation. Let's just keep increasing this by 2 because it's a straight line graph. So it's going to be 2, 4, 6, 8. We now have our set of coordinates, and we can plot our coordinates. So 0 minus 4 is here. 1 minus 2 is here. 2, 0 is here. 3, 2 is here. Again, we can see a bit of a pattern going on here. So rather than looking each individual point, I can just plot them here, and 6, 8 is here. And then we just do a straight line to join them up. Doesn't have to be exactly accurate. So my line's not perfect, but in the exam you need your line to go through all the points and keep it going through to the end of the graph. Part B, we need to start off by drawing the line for both of these inequalities. The way to do this is really to write these as equal signs rather than using the inequality. So we have 2x minus y is equal to 4, and we have x is equal to 1. So we've actually done 2x minus y equals 4 in the first part. So then all we need to do in the second part is x equal to 1. So it should be really easy to draw that line. So now we've drawn the line x equals 1, we just need to look at our inequalities in a little bit more detail. So we have 2x minus y is less than or equal to 4. If we just rearrange this to make y the subject, then we're going to do plus y to both sides, which gives 2x is less than or equal to y plus 4, and then finally minus 4 to both sides. So what you'll note is that y is more than 2x minus 4. So because y is more than, we're going to do upward arrows. And then we have x is more than or equal to 1. So because x is more than or equal to 1, we're going to have arrows going this way. And that's going to be this shaded region. So we have a bakery that delivers boxes of cupcakes in 2 sizes. We have small boxes that have 5 cupcakes and then large boxes that contain 10 cupcakes. The bakery delivers a total of 900 cupcakes such that the number of cupcakes in small boxes to large boxes is in the ratio of 4 to 5. We're then told that the bakery claims that at least 40% of the boxes delivered are small boxes. And then we have to state whether the claim is correct. So the first thing we need to do is set up our equations. So let's call a small box x and a large box y. So if we do 5x, that's given us the total number of cupcakes in our small boxes, because we know that there's 5 cupcakes in each small box. And if we add that to 10y, we're then getting the total number of cupcakes in our large boxes. Now, we know there's 900 cupcakes altogether. That means if you add up your cupcakes in your small boxes and add up your cupcakes in your large boxes, it's going to equal 900. So that's one equation set up. Second equation is going to use this ratio of 4 to 5. So if we have 5x in terms of our small cupcakes, and then we have 10y in terms of our large cupcakes, that will give us the ratio 4 to 5. Because we're told that the ratio 4 to 5 represents the number of cupcakes in small boxes to large boxes. And then we can rewrite this into an equation format by saying 5x over 10y equals 4 over 5. And then we can cross multiply, gives us 25x equals 40y. And then we divide both sides by 5. That is going to give us 5x equals 80y. So what we now have is an equation 1. And we have an equation 2. And this is all we really need in order to answer this question. So let's take our equation 1, right, which we have is 5x plus 10y equals 900. We can simplify this further by dividing everything by 5. That's going to give us x plus 2y equals 180. Let's move the 2y over to the other side. Gives us x equals 180 minus 2y. And then we can substitute that into our second equation. So we're going to say 5 in brackets 180 minus 2y equals 8y. Expanding that out, 5 times 180 is 900. 5 times minus 2y is minus 10y equals 8y. then moving the 10y over to the other side, and we get 900 equals 18y. Then we simply divide both sides by 18 to get our value for y. So our value for y is equal to 50. So remember, y is our number of large boxes. So we know that our number of large boxes is now 50. We can then take that 50 and we can substitute it back into one of our original equations. I'm going to substitute it back into equation 1. So from equation 1, we have 5x plus 10y equals 900. So we can do 5x plus 10 times 50 equals 900. Expanding out, 5x plus 50 equals 900. Sorry, that should be 5x plus 500 minus 500 to both sides. We have 5x equals 400. Dividing both sides by 5, we get x equals 80. So the number of small boxes we have, as x is the number of small boxes, we have is 80, the number of large boxes we have is 50. Our question says the bakery claims that at least 40% of the boxes delivered are small boxes. So all we need to do is 80 over 130 boxes we have in total, and let's see what percentage that gives us. Rounding it gives us 62%. Bakery's claim is correct, as 62% of boxes are small, which is larger than the 40%. Question 4 is trigonometry. We start off by labeling a triangle. So we have the opposite, hypotenuse and adjacent. We're trying to find x, and the two sides they give us are the opposite and hypotenuse, which means that we're going to use sine. So we have sine theta equals O over h. In this case, our x is theta. So we have sine x equals 5 over 14. We need to make x by itself, so we're going to do sine minus 1 to both sides. So x is equal to sine minus 1, in brackets 5 over 14. Whack that into your calculator. They haven't given us a degree of accuracy, so let's use 2 decimal places. That gives us 34.96 degrees. We have a straight line which passes through the points 1, 3 and 4, 15. Find the gradient of the line. So how do we find the gradient with 2 points? We do difference in y divided by difference in x. So our y values is 15 minus 3, and then we have 4 minus 1 for the x. 15 minus 3 gives us 12, 4 minus 1 gives us 3. 12 over 3 gives us 4, so that means our gradient, or we can call it m, or our gradient is equal to 4. Then find the equation of the line in the form y equals mx plus c. Now we know that the gradient is 4, so we have y equals 4x plus c. We need to find c. We can just put one of our coordinates into this equation. So let's just do the easy one, 1, 3. So y value of 3 equals 4, x value of 1 plus c, 3 equals 4 plus c, minus 4 to both sides, gives us a c value of 3 minus 4, which is minus 1, which means that our final equation is y equals 4x minus 1. The mass of the box is measured as 8.4 kilograms, correct to near as 0.1 kilograms. This means that the box can be 0.05 above or below the 8.4 kilograms. So to work at the lower bound, we'll do 8.4 minus 0.05, and to work at the upper bound, 8.4 plus 0.05. So for the lower bound, that gives us 8.35, and for the upper bound, that gives us 8.45. So in order to write it correctly, to get the correct answer, because the lower bound is 8.35, now the way rounding works is it means that can be equal to 8.35. So we're going to do more than or equal to. However, it has to be less than 8.45, because if it was equal to 8.45, then it would round up to 8.5. So we're just simply going to do a less than sign here. So be really careful with your inequalities and your equal to signs. Now for part B, a second box is measured as 0.8 kilograms, which is also correct here, near as 0.1 kilogram. What is the maximum possible total mass of the two boxes? Now, we know from the first box, the maximum possible mass is 8.45. But from the second box, we need to do a very similar exercise. So the upper bound for 7.8 kg, the upper bound is going to be adding 0.05, it's going to be 7.85. So we take our 7.85, we add it to our 8.45. So you then whack that into your calculator and you get an answer of 16.3. So for this question, we're told Sophie's packing a lunch. She has 4 types of sandwiches, 3 types of fruit and some drinks. Sophie says there's 36 different ways that she can choose a sandwich, fruit and a drink. So 36 different combinations. So to work out number of combinations, you have to take your number of sandwiches, times it by your number of fruit and times it by your number of drinks. So we have 4 types of sandwiches times by 3 types of fruit, and then we'll times by X types of drinks. Now that gives us 36. So basically, if X is an integer, that means Sophie could possibly be correct. So 4 times 3 is 12. Times by X, we have 12x equals 36. Divide both sides by 12. Gives us X equals 3. So if there's 3 types of drinks, that means that yes, Sophie would be correct. So in order to get the marks, we just write Sophie would be correct if 3 types of drinks. Question 8, we need to draw a box plot. We're given some information, so this should be fairly straightforward. The minimum is 12. The lower quartile is 27. Median is 35. Upper quartile is 42. The maximum is 55. And then we just need to do the collecting lines for the box plot. So that's our box plot complete. For part B, we need to compare the distribution of the heights of Maggie's plants with the distribution of the heights of Nigel's. So we're given information for Nigel plants. It's 2 marks, so we really want to come up with 2 different reasons. I'd always focus for the 2 reasons on the median, as well as the interquartile range. So we can see that the median for Nigel's is 25, and we know that the median for Maggie's is 35. So I'd put that down as one of the reasons. And then for the interquartile range, we just want to calculate that. So from Maggie's, it's going to be 42 minus 27. So that's an interquartile range of 15. And then doing the same for Nigel's, we have 40 minus 16, 24. So we'll put that down as a reason. So the interquartile range for Maggie is 15, and then the interquartile range for Nigel is higher at 24. So we need to put that down as a reason. So that's 2 reasons done. Another reason we could also talk about is the overall range and comparing that between Maggie and Nigel. But what we've done so far will suffice for this question. So here we have a right angled triangle which is connected to a quarter of a circle. We need to work out this line here, which is the radius, and we can do that by using Pythagoras, as this is a right angled triangle. So we know labeling a triangle, this will be A, this will be B, and this will be C, and the formula for Pythagoras is a squared plus b squared equals c squared. So filling in the blanks gives us a squared plus 8 squared equals 12 squared. Working this out for a, we need to do a squared plus 64 equals 144 minus 64 from both sides gives us a squared equals 80, and then square rooting both sides gives us a equals 8.94. I can see in the answer they wanted to 3 significant figures, so for now I'm going to leave it as 3 significant figures. So we know a, we now know this is 8.94. So if we work out the area of a circle and then times it by 25% or times it by 0.25, that'll give us the quarter of a circle. So we have pi r squared, and then we have pi times 8.94 squared, which gives us 251.09. Let's divide this by 4, and we get 62.77 meters squared for our area of a circle. And then as we need to round 3 significant figures, the answer is going to be 62.8 meters squared. A savings account offers an annual compound interest rate of 4%. Jamil invests 1,200 into the account. Work out his investment after 3 years. Give your answer correct to the nearest pound. So our formula for compound interest is our principal times by 1 plus the interest rate to the power of n. Now we need to write our interest rate as decimal. So we have 1,200. Our interest rate as decimal is 0.04. We're going to add that to our 1 to get 1.04. And our number of years is 3. So we put this into our calculator, which gives us 1,350 to the nearest pound. Now for part B, we have to work backwards. So we're told Jamil's goal is to have at least 1,500 in the account. Calculate the minimum number of years. So we have our formula, which is our initial amount, 1,200 times by 1.04. Now we don't know the number of years, so let's leave that as n. That's what we need to calculate. That gives us 1,500. So simplifying this, let's divide both sides by 1,200. That gives us 1.04 to the power of n equals 1.25. Now let's use the natural logarithm of both sides to bring the exponent down. That's going to be n times ln 1.04 on this side, and then ln 1.25 on this side. Divide both sides by ln 1.04 in order to work out n. So n is equal to ln 1.25 over ln 1.04. Put that into our calculator, and that gives us roughly 5.69, but we need to round up because we need the whole number of years, the minimum number of years. So our value for n is going to be 6. Now, not all of you may know how to use the natural logarithm. I may create a video, and at some point in an exam, if you have to do this question and you don't know how to use it, just simply use trial and error. Keep changing the value of n. Start off with 1, then 2, then 3, then 4. It won't take you that long to get to a number, which in this case is 6, which will take you above the 1,500, and then that will be your answer. So here we have a sequence. Quick interruption, sorry to cut the video, but I just wanted to say I'm working on growing this channel to bring you even more useful content. So if you're finding these papers helpful, subscribe, it really helps me out, and it means that you won't miss out anything that I put out next. Okay, let's get back to it. So here we have a sequence. Let's work out the difference between each term. So we have minus 5, minus 8. Be really careful here with the direction. Minus 11, and then minus 14. And then our differences, let's work out the difference of our differences. So we have minus 3 to each. Now we have our general formula to work out the nth term. And that formula is this. Our A is 10. Our first difference, our D, is minus 5. And our second difference, our C, is minus 3. So let's put our A, D, and C into this formula. which gives us this. And let's simplify. So we're going to need to multiply out this bracket here. We're also going to need to multiply this bracket here and also times a half by -3. So let's do that for the next line. You want to be really careful here, especially when you're multiplying negative numbers. You can definitely lose marks there, so just be very careful when you're multiplying out. So we now have this line. Let's simplify the 10 and the +5, which gives us 15. So we have 15 minus 5n, and then let's also multiply out this bracket. And then finally, let's bring our minus 1.5n squared to the front, and let's simplify everything else. So we get minus 0.5n, and then we have 15 minus 3, which is plus 12. It's always worthwhile taking potentially the third term, putting 3 into your formula, and seeing if that gives us an answer of minus 3. In this case it does, so we can move on to the next question. Then for part B, we need to use our formula for part A to work out the 20th term of the sequence. So we're just going to make n equal 20. Let's put that into our formula. So we have minus 1.5, 20 squared, minus 0.5 times by 20, plus 12. Put this into your calculator to simplify, and that gives you minus 598, which is our answer to part B. Fairly straightforward algebra question. We just need to expand out 3 brackets. So always expand out the first 2 brackets first. So x plus 3 and x minus 2. When we expand that out, we get x squared minus 2x plus 3x minus 6, which gives us x squared plus x minus 6. Now we put this in a bracket, and we need to multiply this by x plus 5. So let's expand this out. We have x cubed plus 5x squared plus x squared plus 5x minus 6x minus 30. Simplifying this all out, we've already got it in the right order, so we're going to have x cubed, 5x squared plus x squared is plus 6x squared, 5x minus 6x is minus x, and we have minus 30, which is our answer for question 12. We have a factory that produces 8,000 toys. Then we have a sample of 200 toys, and 12 of them are found to be defective. So we need to estimate how many defective toys are in the entire production. So the first thing we need to do is work out the probability of toys from our sample that are defective. So that's going to be 12 out of 200. And then we just simply need to times that by our 8,000 toys, and that gives us 480 toys. So the factory wants to ensure that no more than 1.5% of the toys are defective. So let's take our 8,000 toys and multiply by 1.5%. That gives us 120. Now 480, our answer from part A, from our sample, 480 is more than 120, which is the standard. So no, the production batch does not meet the standard. So for this question, we have a transformation. We need to rotate the shape A 180 degrees about the point 10. So let's start off by marking where point 10 is, which is here. Then I use a compass method in order to do this question. So we have up, right, down, left. So if we take this point from our point 10, we go 2 up and 2 left. Applying the compass method to that makes 2 down and 2 right. So we're going to go 2 down and 2 right for this point here. Then to get to this point here, we have to do 4 up and 3 left. So that's going to make 4 down, 3 right. It's going to make this point here. And then our final point, we have 2 up and 4 to the left. That's going to make 2 down and 4 to the right. So it's this point here. And then we simply join up the points, and we've then got our rotated shape. So here we have a histogram. We have the ages and years of the members of a dart club. So there's 22 members with ages in the range of 40 to 65. So that's this area here. Remember, the area represents the frequency. We need to work out the number of members with ages in the ranges 25 to 40. There's a couple of ways we can do this. So the way I'm going to do is by first working out the axes for the frequency density, but specifically looking at the 40 to 65 range, because that's the information that they've given us. So in order to work out frequency density, we need to do frequency divided by class width. So in this case, the frequency is 22. We divide that by 25. That gives us a frequency density here of 0.88. Now, working backwards, right, we need to work out the number of members with ages in the range of 25 to 40. So this whole area between 25 to 40 here, we need to work that area out. That will give us our frequency, which will give us essentially the number of members. So in order to do that, we need the class width, which we know is 15, and we need to work out what frequency density to times it by. So if we have 0.88 and it's 11 boxes high, we need to see how many boxes high is it to get to here, and that will give us our frequency density. So we have 5, 10, 15, 20, 25, 30. So we're going to do 0.88. We're going to divide that by 11 and times that by 30, which gives us 2.4. Then to do the final step, which is simply work out the frequency, we're just going to do 15 times by our 2.4, which gives us 36 members. So here we have the diagram of an ice hockey park. It's in the shape of a cylinder. Radius is 3.8 centimeters. We have a thickness of 2.5 centimeters. It's made out of rubber with a density of 1.5 grams per centimeters cubed. We need to work out the mass. So in order to work out the mass, first we're going to need to work out the volume. Once we've worked out the volume, we can times that by 1.5 grams, and that will give us our answer. We have to also remember to put it into 3 significant figures. Failure to do so will mean that we lose a mark. So let's work out the volume first. In order to do that, we need to work out the area of this cross section. So to work out the area of the cross section, we simply work out the area of the circle. Area of a circle, we should all know, is pi r squared. So in this case, it's going to be pi times 3.8 squared, which gives you 45.36. You'll note that I've actually got this as more than 3 significant figures, and I'm using a larger degree of accuracy at the moment. At the end, I'll make sure it's within 3 significant figures. So that gives us our area of the cross section, the area of the circle at the top, volume of the cylinder, so 45.36. We're going to times that by 2.5, which gives us 113.4. So we now have the volume, which is 113.4 centimeters cubed. We then take 113.4, we times that by 1.5, as is 1.5 grams per centimeters cubed, and that gives us 170.1 grams. Okay, so we need to be very careful here, because we may think this is the final answer, but remember, it needs to be in 3 significant figures, and that's the way they're going to trip a lot of you up. So rounding this to 3 significant figures gives us simply 170 grams, and that is the final answer. Question 17, we've got a triangle ABC. They're giving us a few different lengths. So question 17, we've got a triangle ABC. They've given us a length of a couple of the sides, as well as one of the angles. So let's draw this triangle up. So let's call this A, this B, and this C. And then for AB, we have lengths of 7 centimeters. For For BC, we have lengths of 9 centimeters, and we also know that the angle B is 120. And we need to work out the length AC. Let's label our triangle. Straight away, I'm going to do it in a different color pen because I think it could get really confusing with our A's, B's, and C's. So let's use a green color pen. So let's call this big A, as this is the angle which they've given us. Hence, this then has to be small a, and then this can be a small b, and this can be small c. It doesn't really matter which way around it is. We have our formula for cosine rule. It's a squared equals b squared plus c squared minus 2bc cos big A. Now putting all of this in, we have our a squared, which is still unknown. Our b squared is going to be 7 squared. C squared is 9 squared. And we have minus 2 times 7 times 9 cos 120, which is our angle. I like to do this next part in a couple of steps. So firstly, I want to do 7 squared plus 9 squared. So that gives me 130. Then we have minus 2 times 7 times 9, which gives us minus 126. And our cos 120. It's at this stage that I want to put into a calculator, and that gives us 27.41 to 2 decimal places. We then square root both sides, and we have our value of A, which is 5.24. So remember that our A is the length AC, so we have AC is equal to 5.24 centimeters. So you have to be very careful in terms of the letters that we're using and to not confuse them with the purple ones. Now to calculate the area of triangle ABC, we're going to use our advanced trigonometry formula to work out the area of a triangle, and that is the formula half AB sine big C. So C is the angle which is wedged between our two lengths. Now in this case, our angle is A, right? And A is the angle A, which is 120, is wedged between 7 and 9. So we're going to rewrite this slightly and say half BC sine big A, which gives us a half 7 9 sine 120. Put that into the calculator, and you have 18.29 centimeters squared, and this is correct 2 decimal places. So here we have a probability question. There's n counters in a bag. 4 of them are green, the rest are yellow. Sam takes a counter at the bag from random. A really key piece of information is that he does not replace it. He then takes another counter at random from the bag. The probability Sam takes 2 yellow counters is a third. Show that n squared minus 13n plus 30 equals 0. So we're going to have to set up an equation and make it equal to a third. The key bit of information here is there's 2 yellow counters. We don't need to draw a whole tree diagram out, but we can do the yellow element of it. So we have our first pick and we have our second pick. And in both instances, from our first and second, we're interested in picking a yellow because multiplying them together is going to give us a third. So for our first pick, we have n counters in total. If 4 of them are green and the rest are yellow, we must have n minus 4 for our numerator. Then for our second pick, if we've already picked a counter and not replaced it, we're going to have n minus 1 for our denominator. And for our numerator, well, we had n minus 4, we picked a yellow, we now have n minus 5. So we can write out n minus 4 over n times by n minus 5 over n minus 1. That gives us 1/3. Imagine there's brackets around everything as well. It makes it easier when it comes to multiplying out. So let's multiply the numerator n minus 4 times n minus 5. That gives us n squared minus 9n plus 20. For our denominator, we have n times n minus 1. Gives us n squared minus n equal to a third. Let's cross multiply it by multiplying the numerator on the left by 3 and the numerator on the right by n squared minus n. Gives us 3n squared minus 27n plus 60 equals n squared minus n. Then we can do minus n squared to both sides. We can also add n to both sides as well. Gives us 2n squared minus 26n plus 60 equals 0. Finally, we can divide every number by 2, which gives us n squared minus 13n plus 30 equals 0. So going back to part A, we've shown that n squared minus 13n plus 30 equals 0. So for part B, we have to solve the quadratic. Because it's a probability question and n represents the number of counters, it must be a whole number. So we're going to have to use the m and the a method. M has to be 30, and then we need two numbers to add to give minus 13. Be careful here. Some people may say 15 and 2, but actually the two numbers are minus 10 and minus 3 because they multiply to give 30 and they add to give minus 13. So we put that into brackets, and minus 10 and minus 3 equal to 0. So our two solutions we have initially are n equals 10 and n equals 3. Now, if we go up, our question has 4 counters which are green. So our total counters in the bag cannot possibly be 3 if we know that 4 of them are green. So that means that we actually have 10 counters in the bag. So our solution for n is equal to 10. Okay, so the given equation is x cubed minus 3x plus 1 equals 0. So we need to rearrange this essentially to make x a subject. Let's start off by isolating the x cubed. So we're going to do minus 1 to both sides, gives us x cubed minus 3x equals minus 1, then add 3x to both sides, gives us x cubed equals 3x minus 1, then we simply cube root both sides, and we have x equals the cube root of 3x minus 1. So we've now rearranged it and it's valid, and we can then use this formula for the iteration. Okay, so for part B, we're given the iterative formula. From part A, we're given the value of x1, told is equal to 1. We need to find the value of x5, the fifth iteration. So we need to go through our iterations and give an answer to 3 decimal places. So let's work out the second iteration. So I'm going to put x small 2 here. Remember, this is n plus 1, so it's going to be one iteration higher than what we put into the equation. So cube root of 3x1, which is a value of 1 minus 1, and let's solve that to get cube root. 3 times 1 is 1, minus 1 gives us 2. So we have the cube root of 2, which is 1.25992105. Let's do the next iteration. So we're going to use our value from here. For the sake of our question, I'm going to take this to 3 decimal places. But of course, in your calculator, you can just use the answer button and hence put the whole number in there. So we're going to do cube root of 3 times 1.2, let's do 2599 actually, so 4 decimal places, minus 1. We put that into our calculator and we see what does that give us for our third iteration. 1.406055,935. Then we can do the fourth iteration, exactly the same process, so by now you should have the hang of it. 3 times 1.4061 minus 1, let's see what that gives us. 1.47639612, and then finally let's do our fifth iteration. Times 0.4764 minus 1, which gives us 1.5079853. So we need to give the answer 3 decimal places. We're going to cut it off here. So our fifth iteration is equal to 1.508. So question 20, which is our final question, they've given us a sketch of the curve y equals sine x. They've asked us to write down the coordinates of the point P. So we know from our sine curve, we know a couple of things. Let's just quickly write them down. We know this point is 1. We know this point here is minus 1. We also know this is going to be 180. And we know this is going to be 360. So with that information, the point P is going to be 180, 0. And then for the point Q, which is here, well, it's halfway between 180 and 360. So half of 180 is 90. Adding that onto 180 gives us 270. So our coordinate is going to be 270 for the x, and then our y is minus 1. Moving on to part C, they've given us a cost curve, however they've applied a few different transformations to it. So looking at the curve here, we have a cos bx plus c. So that means that they've done something to the y-axis in terms of a stretch. They've done some sort of stretch to the b-axis, and then they've done a movement to the y-axis. So let's work out what these three are. So starting with our a, which is our stretch along the y-axis. So normally our range for our y in the cos curve, our range is 2. Starts at 1 and it ends at minus 1. Here you can see our range between 3 and minus 1 is 4. So that means there's been a stretch of 2 for our y-axis. So hence a is equal to 2. Let's do C first before we come back to B. So for C, that's going to be our movement along the y-axis. So now you have to think we've now stretched it along the y-axis. So our normal cos curve starts at 1. We've stretched it now here at 2. We moved it up by 1. So that means we can have 1 for our value of C. So finally for B, what stretch have we got along the x-axis? Look at our stretch along the x-axis. Normally we would have one wave between 0 to 360. But here you can see there's actually 3 waves. We've got one wave here, another wave here, and another wave here. So we've got 3 waves, so really we're compressing it by 3. But because it's along the x-axis, we have to write it as the inverse, so our compress of 3 is actually going to be a multiply of 3. So our value of B is going to be 3. So to summarize, we have A is equal to 2, B is equal to 3, and C is equal to 1. I'm keeping the grade boundaries the same as paper 1. In order to get a level 9, you need to get 70 out of 80. This is a little higher than what you'll see in the practice pass papers that you've probably seen at school and what you'll see on the Edexcel website, but I make up the papers as challenging as possible. I want it to be as hard as possible for you to get a level 9 in my papers, because if you're getting a level 9 in my papers, you're going to absolutely smash it when it comes to the real exams. Okay, so that's it for paper 2. I'm hoping to get paper 3 out in the next week or 2, so if you want to be the first to get it, make sure to subscribe. That way you won't miss it when it drops. Thanks for watching, and I'll see you on the next one.